Hi, I'm News 9 Chief Meteorologist David Payne. Today we're going to talk about how tornadoes form. In Oklahoma, we are unfortunately all too familiar with tornadoes, especially during spring. It takes a special storm in the right atmospheric conditions for tornadoes to develop. So why do we seem to have so many tornadoes? We are not in this alone. This map shows all of the tornado tracks since 1950 across the U.S. Many states east of the Rockies have tornadoes. It is true that the United States has more tornadoes than any other country on the planet. So why is this? Well, it's all about location. Well, to get severe weather in Oklahoma, you have to have a couple of ingredients coming together, and we have those often during the springtime, right? We're talking about the warm, moist air from the Gulf of Mexico. We're very close to the Gulf, so that comes in from the south. At the same time, the jet stream at around 15 to 20,000 feet up, pretty high in the atmosphere. That's going to be bringing in cool, if not cold, dry air. And when these two ingredients come together with the warm, moist air down low and the cold, dry air up top, these ingredients come together to give us severe weather, and that includes tornadoes. So how do tornadoes form? Well, even before there is a cloud in the sky, something interesting begins to happen in the very lowest levels of the atmosphere. You have wind blowing at different directions with height, okay? As you go from the lowest levels of the atmosphere to a little bit higher in the sky, these winds will be changing directions, all right? And that's what we call wind shear, and that produces an invisible horizontal spinning tube, all right? Now that tube by itself spinning won't do a whole lot. If we can get a thunderstorm along maybe a cold front or a dry line to develop, that horizontal tube will be lifted into the vertical, all right? So it's going to be up and down. Our storm continues to develop. It now has that vertical tube inside. At the same time, we have the winds coming in from the west and southwest with the jet stream, and that will, again, act on our storm and continue to make it spin. It will become faster and spin faster and become stronger as our storm begins to strengthen. All right, now this area spinning in here becomes what we call a mesocyclone, or an area just of low pressure, just an area of low pressure spinning in the sky. Our thunderstorms continue to grow, and at one point this thing could be as high as 60,000 feet and or higher, all right, so very high in the sky. The wind continues to increase, wrapping around our storm, making our storm spin faster and faster. And remember, we have that cold or that cool, dry air coming in out of the southwest, and that will really tighten up our mesocyclone. Our supercell is rotating. We get, of course, a funnel, and then followed by the funnel, you'll get that tornado. That's how a tornado forms. So this is what our rotating thunderstorm or our supercell looks like on Storm Shield 9. This shot here was taken from May 20th of 2013. This was a horrible, devastating tornado for Moore. Remember, this was an EF5 tornado, one of the strongest on the planet. All right, was moving through Moore, and there it is. That's the hook that we talk about. There's our storm, large storm. That's the updraft or the mesocyclone or the area of rotation right there. Let's put this into movie mode. You can see this. Again, supercell, rotating thunderstorm, moving through Moore, and as it moves off to the east, our hook begins to go away. That's because that storm began to weaken, and our tornado weakened and finally fell apart. Let's zoom in here a little bit closer, and I'm going to show you something else. Now, there's our tornado. Right in the middle of that hook is where the tornado is, but also notice how large that is. Our tornado is not 2 miles wide, all right? What you're seeing is we call this a debris ball. This is showing you the rain, the hail. Storm Shield 9 is picking that up. Also showing you, though, debris that is being lofted or thrown in the air, whether it's neighborhoods or whether it's businesses. The radar is showing you exactly how large that debris ball is. And at this point, it was over 2 miles wide. The debris ball was. The tornado at this point was an EF5. And again, it was about 1 mile wide. So just an incredible presentation there from Storm Shield 9. Okay, let's go to our shear rate product, only on News 9. What is that? Well, remember shear, that is turning or spinning in the atmosphere. And where you see the maroons with the yellows in the center, that's where the rotation is at its highest, okay? Very, very strong rotation coming into southwestern sides of Moore with that storm, all right? That's what it looked like back on, again, May 20th of 2013. Let's go to our velocity data. This just simply shows you wind speeds, okay, how strong the wind is blowing by using Doppler radar. And where you see the bright oranges up against the dark blues, that is where winds are well over 200 miles per hour. And that's telling me that there is again, a strong tornado on the ground. Well, you know, tornadoes come in all shapes and sizes. Some are very thin, some are dark, some are white, some are very, very large. But most tornadoes are weak, don't last very long. It's tornadoes like this, the large and violent tornadoes that we have to worry about. Here in Oklahoma, we average about 55 tornadoes a year, most of those occurring in the month of May. Living in Oklahoma, tornadoes, they're just a way of life. But with 2 helicopters and the largest team of meteorologists and trackers in the country, you can count on News 9 to keep you and your family safe day and night. Stay with News 9. We'll keep you advised.